In secondary neurulation, we expect the process to be quite different from primary. Alright, so in this process, make the um, formation of the neural tube is not going to start from the development of a plate that sinks down then encloses to become a tube. In secondary neurulation, a solid medullary cord is developed initially and then later on it will sink towards the coelomic cavity. It will hollow out and become continuous with the primary neural tube. In terms of location, primary secondary neurulation happens or is observable in lumbar or caudal vertebra, so more posterior portions of the spinal cord. No, in frog and chicken, it occurs in the neural tube, primarily neural tubes, so higher parts, and lumbar vertebra. So here we're seeing three panels of um, pictures representing the process of secondary neurulation. Let's first talk about the steps that are required for secondary neurulations to happen. Initially, condensation of mesenchyme happens beneath the tail bud, beneath the dorsal ectoderm of the tail bud, as represented in letter A. So there's condensation of mesenchymal cells here, forming a medullary cord, no? A medullary solid cord. This one. Later on, after this solid cord has been formed, a canal will be developed. This canal is central and will actually develop by means of the process of cavitation. This canal, so you can see on this picture in letter C, this one, space, this canal, as a as a culmination of secondary neurulation will become nearer, right? This canal here, that's a result of the major cavitation of the neural tube, will become continuous with the primary neural tube. Let's describe secondary neurulation in different vertebrate animals. Uh, in fishes, we may say we expect that the formation of the neural tube is purely or exclusively secondary neurulation. So there's no primary neurulation in fishes. In birds, anterior portions of the animal, anterior portions of the neural tube, okay, is produced or are produced by primary induction, primary neurulation, while neural tube that will be caudal to the 27th somite pair. So let's say the 27th somite pair has been produced already. Everything caudal to it, alright, is going to be produced by secondary neurulation. For amphibians such as the frog xenopus, right, most of the neural tube of the 9 millimeter tadpole is derived from primary neural induction, primary neurulation. The tail portion, however, of the neural tube is derived from secondary. In mammals like mice, probably we have sufficient evidence that it's probably in humans might be the same case. For mice and humans, primary neurulation and secondary neurulation takes place. Secondary neurulation begins at the level of the somatic pair number 35. So somatic pair 36, and then caudal, and then more caudal, probably is produced by secondary neurulation. Okay, so we have concluded the processes involved in neurulation, primary and secondary neurulation. Let's now examine what are the structures that will be developed after the neural tube accomplishes closure, you know, and later on will actually specialize the central nervous system. So on this part, we're going to talk about special structures that will arise, you know, from the neural tube. Now, the special structures actually arise from the neural tube in a later time. We should expect that initial changes happened first. Some of these changes include the formation of brain chambers, right, and spinal cord chambers or brain spinal cord ventricles.